Dark silhouettes stretch across the American landscape, from Alaska's icy peaks to the steaming islands of Hawaii, from the forests of the Pacific Northwest to the high plateaus of Wyoming. They are mountains admired for their beauty, climbed by adventurers, photographed by millions, and celebrated as symbols of untamed wilderness. Yet scientists studying these giants do not measure them by scenic value alone. They examine how frequently they erupt, the kinds of magma hidden below, the speed at which volcanic hazards can unfold, the number of people living nearby, and the critical infrastructure that stands in harm's way. When all of those factors are combined, a clear picture begins to emerge. Some volcanoes are active, but relatively isolated. Others have the power to affect entire regions, even during modest eruptions. A select few possess the potential to transform life across vast portions of the United States within hours. That scientific assessment forms the foundation of the United States Geological Survey's volcanic threat rankings, a system that considers dozens of characteristics instead of focusing solely on eruption size. A volcano capable of producing an enormous eruption once every several 100,000 years may rank lower than another that erupts frequently near major communities. Likewise, a mountain with explosive potential but few nearby residents may pose less overall danger than one whose hazards extend into densely populated valleys. The result is not a ranking of the biggest volcanoes or the tallest volcanoes. It is a ranking of the greatest overall threat to people, infrastructure, transportation, and the economy. Beginning at number 10 is Mount Adams, a giant that often escapes public attention despite being one of the largest volcanoes in the Cascade Range. Rising about 12,280 feet, or approximately 3,743 meters, Mount Adams dominates southern Washington with broad glaciers, lava flows, and rugged volcanic ridges. It is part of the Cascade Volcanic Arc, formed as the Juan de Fuca Plate slowly sinks beneath the North American plate, fueling volcanism across the Pacific Northwest for millions of years. Unlike some neighboring volcanoes, Mount Adams has remained quiet for a long time. Geological evidence shows its last confirmed eruption occurred about 1,000 years ago. Since then, glaciers, snowfall, and erosion have softened its volcanic features, making it appear stable. Scientists stress that Mount Adams is still an active volcano. Its magma system remains beneath the mountain but is currently dormant. Its lower ranking reflects the lack of warning signs. Monitoring shows little earthquake activity, limited ground deformation, and no evidence that magma is rising toward the surface. Even so, Mount Adams still poses hazards. Its glaciers contain vast amounts of ice and snow, and even a moderate eruption could trigger fast-moving lahars made of volcanic debris, melted ice, mud, and water. These destructive flows can race through river valleys and have caused severe damage at other Cascade volcanoes. Fortunately, few people live near Mount Adams compared with higher-ranked volcanoes. Although an eruption could disrupt aviation, agriculture, highways, and nearby communities with ashfall and lahars, the overall risk to people remains lower because no major metropolitan areas lie directly beside the volcano. At number 9 stands Lassen Volcanic Center in Northern California, one of the most geologically diverse volcanic systems in North America. Unlike a single mountain, Lassen is a vast volcanic complex containing lava domes, cinder cones, shield volcanoes, hydrothermal areas, boiling mud pots, fumaroles, and extensive geothermal activity. This diversity reflects a complex magma system capable of producing many types of eruptions. Lassen earned its place in American history when Lassen Peak erupted repeatedly between 1914 and 1917. Those eruptions produced steam explosions, lava dome growth, pyroclastic flows, ash clouds, and lahars. One powerful eruption blasted ash thousands of feet into the atmosphere while devastating nearby forests with hot avalanches of rock and gas. These eruptions are very recent in geological terms. While many Cascade volcanoes have remained quiet for thousands of years, Lassen was active only about 1 century ago, making it a higher priority for scientists. Its geothermal landscape shows that heat still lies close to the surface. Boiling springs, sulfur-rich steam vents, and bubbling mud pools reveal groundwater interacting with hot volcanic rocks below, confirming the volcanic system remains active. Scientists continuously monitor earthquake swarms, gas emissions, and subtle ground movement. Small earthquake clusters occur from time to time, usually reflecting changes within the crust rather than an imminent eruption. Even so, every event is carefully studied because volcanoes often show subtle warning signs before larger activity. Lassen ranks lower than several Cascade volcanoes, mainly because relatively few people live nearby. Although renewed eruptions would disrupt Northern California with ashfall and volcanic hazards, the number of people at risk remains much smaller than near volcanoes closer to major cities. Moving up to number 8 is one of the most recognizable volcanoes on Earth, Mauna Loa. Occupying much of Hawaii's Big Island, Mauna Loa is the largest active volcano on the planet by volume. From its base on the ocean floor to its summit, it rises more than 30,000 feet, or over 9,140 meters, making it taller than Mount Everest when measured from base to peak. Its immense size was built by repeated eruptions of highly fluid basaltic lava over hundreds of thousands of years. Instead of forming a steep cone, Mauna Loa developed into a broad shield volcano with gentle slopes stretching across a vast area. Its eruptions are very different from those in the Cascade Range. Rather than violent explosions, Mauna Loa usually produces fast-moving lava flows that can travel long distances. Some have reached the ocean while destroying everything in their path. The volcano's recent history shows this threat is still real. Mauna Loa erupted many times during the 20th century and most recently in the year 2022, after nearly 4 decades of quiet. Lava fountains lit the summit while molten rock flowed along established rift zones. Fortunately, the eruption stayed within expected areas, avoiding major population centers. Scientists closely monitor Mauna Loa using earthquake sensors, gas measurements, ground deformation, satellite observations, and gravity studies. Before eruptions, the volcano often inflates as magma rises beneath the surface, while earthquake activity increases as molten rock forces open cracks in the crust. Despite its enormous size, Mauna Loa ranks below several mainland volcanoes because its eruptions are generally more predictable than highly explosive systems. Lava flows can destroy roads, homes, utilities, and infrastructure, but they usually move slowly enough for evacuations. Even so, the danger remains serious. Lava flowing only a few miles per hour can overtake buildings, cut off highways, isolate communities, ignite vegetation, and permanently reshape the landscape. Once molten rock begins moving downhill, there is little that can stop it. At number 7 is Mount Hood, Oregon's highest peak and one of the most closely watched volcanoes in the Pacific Northwest. Rising about 11,249 feet, or roughly 3,429 meters, Mount Hood stands less than 50 miles east of Portland. Its snowy slopes attract climbers and skiers, while nearby towns, highways, and reservoirs surround the volcano. Although it has not produced a major eruption in recent centuries, geological evidence shows its last eruptive period likely ended during the late 18th century, making it dormant, not extinct. Scientists closely monitor Mount Hood because its glaciers could rapidly melt during even a small eruption, triggering destructive lahars that can race through river valleys toward populated areas. Its location near Portland greatly increases the threat. Even a moderate eruption could spread ash across the region, disrupting air travel, transportation, power, water supplies, agriculture, and businesses. Experts say Mount Hood's greatest danger may come from moderate volcanic activity, combined with hazards such as ashfall, lahars, volcanic gases, and localized pyroclastic flows. Although the volcano remains quiet today, the tectonic forces beneath it continue building the conditions for a future eruption. At number 6 is Yellowstone caldera, one of the most famous volcanic systems on Earth. Unlike a towering volcano, Yellowstone is a vast volcanic depression hidden beneath forests, rivers, lakes, and geysers. Measuring about 30 miles from north to south and 45 miles from east to west, it was formed by an enormous eruption hundreds of thousands of years ago. Many expect Yellowstone to rank first, but scientists focus on realistic hazards rather than worst-case scenarios. Its magma system is still active, yet most of it consists of partially melted rock, with only a small amount capable of erupting. Yellowstone experiences thousands of small earthquakes each year, along with gradual ground uplift and sinking. These changes are closely monitored but usually reflect normal volcanic and hydrothermal activity rather than signs of an imminent eruption. The park's geysers, hot springs, mud pots, and steam vents show that tremendous heat still exists beneath the surface, making Yellowstone one of the world's most active geothermal regions. Yellowstone ranks 6th because the chance of another giant caldera forming eruption is extremely low. The last occurred about 640,000 years ago, and scientists consider smaller lava eruptions, hydrothermal explosions, or regional ashfall far more likely. Even a moderate eruption could disrupt aviation, transportation, agriculture, and communities across parts of the western United States. However, the overall risk remains lower than the more frequent threats posed by several volcanoes ranked above it. At number 5 is Mount Baker, a snow-covered volcano in northwestern Washington. Rising about 10,781 feet, or roughly 3,286 meters, Mount Baker is one of the snowiest places on Earth. Its massive glaciers create one of its greatest hazards. Although it has not produced a major eruption in modern history, Mount Baker remains active. During the 1970s, increased steaming and hotter fumaroles raised concerns, reminding scientists that the volcano is still alive. Its location increases the risk. Nearby communities, highways, reservoirs, and hydroelectric facilities lie along river valleys where lahars could rapidly travel. The volcano's glaciers add to the danger. Hot volcanic material can quickly melt thick ice, creating powerful debris flows of water, ash, and rock, capable of sweeping away bridges, vehicles, and forests. Scientists closely monitor volcanic gases, earthquakes, satellite data, and ground deformation for signs of unrest. Mount Baker ranks higher because its steep valleys can channel destructive lahars directly toward developed areas, despite its relatively quiet recent history. Number 4 belongs to Mount Shasta, one of California's most impressive volcanoes. Rising about 14,179 feet, or roughly 4,322 meters, Mount Shasta dominates Northern California. Though it appears symmetrical, it was built by multiple overlapping volcanoes over hundreds of thousands of years. Mount Shasta is one of the most active volcanoes in the Cascade Range. It has erupted many times during the past 10,000 years, with its most recent significant eruption occurring only a few centuries ago. Its silica-rich magma can produce explosive eruptions with towering ash clouds, pyroclastic flows, volcanic bombs, and widespread ashfall. Thick glaciers also increase the risk of destructive lahars that could surge through nearby valleys. As Northern California has grown, more roads, railways, power lines, and communities now lie within potential hazard zones. Scientists continuously monitor earthquakes, ground movement, volcanic gases, satellites, and global positioning system stations to detect early signs of unrest. Mount Shasta ranks this high because it combines a long history of explosive eruptions with the potential to threaten both nearby communities and large areas across the western United States. Number 3 is Mount St. Helens. Before the year 1980, Mount St. Helens was a nearly symmetrical snow-covered volcano. On May 18, 1980, a magnitude 5.1 earthquake triggered the collapse of its northern flank, releasing a powerful lateral blast that became one of the most studied volcanic disasters in history. The eruption flattened forests, unleashed pyroclastic flows, filled rivers with volcanic debris, and sent ash across multiple states before it spread around parts of the world. It also changed how scientists understand volcanic hazards, proving that sideways blasts can be just as devastating as vertical eruptions. Mount St. Helens has remained active ever since. Eruptions continued through the 1980s, followed by new lava dome growth during the early 21st century inside its massive crater. Today, scientists closely monitor earthquakes, ground deformation, volcanic gases, and magma movement because the volcano has repeatedly become active within decades rather than centuries. Its high ranking reflects both its frequent activity and its ability to produce ashfall, pyroclastic flows, landslides, lahars, volcanic gases, and other dangerous hazards that threaten parts of western Washington. At number 2 is Kīlauea, Hawaii's most active volcano and one of the busiest volcanic systems on Earth. Unlike neighboring Mauna Loa, Kīlauea is a broad shield volcano built by countless eruptions of fluid basaltic lava. It has spent more years erupting than resting, making it one of the world's best-studied volcanoes. Its high ranking comes from constant activity rather than massive explosions. Eruptions can last for months or even years, destroying homes, highways, forests, power lines, and permanently reshaping the coastline. The eruption that began in the year 2018 showed its destructive power. Lava burst from new fissures along the lower East Rift Zone, destroying more than 700 homes, forcing thousands to evacuate, and creating new land where lava entered the Pacific Ocean. At the same time, repeated collapses at Halemaumau crater generated thousands of earthquakes. Since then, Kilauea has continued erupting, proving that volcanic activity is its normal state rather than a rare event. Its hazards extend beyond lava. Volcanic gases create fog, reducing air quality across parts of Hawaii, while ground cracking, unstable lava deltas, localized explosions, and earthquakes add to the danger. Scientists monitor Kilauea with one of the world's most advanced volcanic monitoring networks, allowing many eruptions to be detected before they begin. Even so, the volcano can change rapidly as new fissures open and lava shifts direction with little warning. That constant activity and its direct impact on nearby communities place Kilauea just below the nation's most dangerous volcano. At number 1 is Mount Rainier, widely regarded as the most dangerous volcano in the United States. Rising about 14,411 feet, or roughly 4,392 meters, above western Washington, Mount Rainier appears peaceful but hides the nation's greatest volcanic threat. Its greatest danger comes from its glaciers. Mount Rainier holds more glacier ice than all the other Cascade volcanoes combined in the contiguous United States. Even a moderate eruption or a large landslide could rapidly melt that ice, producing massive lahars of water, volcanic ash, rock, and debris that can race more than 50 miles through river valleys. Geological evidence shows this has happened many times. About 560 years ago, the electron mud flow swept through valleys that are now home to growing communities, major highways, and critical infrastructure. Unlike lava, lahars move fast, sometimes exceeding 30 miles per hour, leaving little time to escape. More than 150,000 people now live in valleys shaped by these ancient flows, making Mount Rainier's location especially dangerous. Scientists closely monitor the volcano with earthquake sensors, gas measurements, satellite observations, ground deformation instruments, and lahar detection systems. While they do not expect an eruption without warning, some communities could have only minutes to evacuate if a large lahar begins. Rainier can also produce explosive eruptions, pyroclastic flows, ashfall, landslides, and volcanic gases. However, scientists consider lahars the greatest threat because they can occur during relatively small eruptions or even from the collapse of weakened volcanic rock. There is no evidence that Mount Rainier is preparing to erupt today, but it is still an active volcano. As the Juan de Fuca plate continues sinking beneath North America, the same tectonic forces that built the Cascade volcanoes remain at work, ensuring Mount Rainier will one day erupt again.